Hi, welcome back to Moose and Chemistry. This is Charles Law, gas problem, lesson 8. So when we talk about Charles Law, that is a relationship between volume and temperature, where our pressure is always constant. Originally, Charles Law is written as V1 over T1 equals V2 over T2. But that's kind of hard dealing with fractions. So what we do is we simply move this up here and that up there to get this equation here, which is a lot easier for your brain to read, actually. Also, another thing you want to do is you want to make sure that your temperatures are not in Celsius, but they're in Kelvin. All right, so let's look at the problem here. A balloon is released in a park and rises skyward. The original volume of the balloon was 3 liters. At a temperature of 30 degrees Celsius. As the balloon rose to 10,000 meters, the temperature decreased to negative 100 degrees Celsius. What is the volume of the balloon? The new volume that we're talking about. Okay, well, let's look at that. All right, so the first thing we want to do is we want to write down V1, T1, V2, T2. This is an easy way to keep everything kind of like organized. Makes doing the problem a whole lot easier, trust me this. So the first volume is 3 liters. But we know we can't use Celsius here, right? So we want to turn 30 Celsius into Kelvin. So we go K equals C plus 273.15. Pretty simple, huh? So you just put a 30 there, right? And you add it to 273.15, and that gives us our new T1 temperature, and T1 is going to equal 303.15 K. So let's go ahead and do that there. So our temperature is now 303.15 K. So our second volume, that's our new volume, we don't know what it is. Our second temperature was negative 100 degrees Celsius, right? So we have to do another one of these things here. So we use the same thing. So let me go ahead and do the eraser here. Get the eraser, there we go. And I'm going to erase this right here real quickly, since we already have that temperature involved. And let's go back and get our pen again. There we go. And so this time we're going to say K equals negative 100 Celsius plus 273.15. So that means K is 173.15 K. And this K is actually going to be our T2 temperature, right? So our T2 temperature is 173. So now let's go ahead and clean this up one more time. So we have plenty of space to work with. So we'll clean all that up here. And while we're at it, we'll clean that up too. And notice that I'm not doing anything with height. The height, the fact that the balloon is 10,000 meters up doesn't mean anything as far as we're concerned. All right, so now let's go ahead and write our formula. V1 T2 equals V2 T1. And we derived that by what we did up there at the top. So we want to isolate for V2. So that means we're putting V2 on the left. Then we're going to go V1 T2. And then we're going to move the T1 underneath, just like that. See that? So that works pretty darn well. Okay. So now what we're going to do is we're going to take and we're going to put in our values. And our values are what we got from our list right here. So we go V2 equals V1, which is 3 liters, times our T2 temperature, which was 173.15 K. See that right there? And divide that by our T1 temperature, which is 303.15 K. All right. So now you see that you have K's on top and K's on bottom, so you cancel that out. That means we're going to solve this in liters. So our V2 value is going to equal on top, calculate that real quick, 519.45 liters. See that? And then we're going to divide that by 303. 1.5. So when we do that, our new volume is going to be, let's go do that real quickly, 1.71 liters. And that makes sense because this is what we call a direct relationship. As the temperature increases, so with the volume. So that means that if we did it on a graph like this, as temperature increases, volume increases. So that makes sense. Well, I hope you liked this video. Give us a like and consider subscribing so we can grow this channel. You guys be snarly, and we'll see you back here at Moosine Chemistry!